Manufacturers recommend that the engine coolant circulating inside the engine and the radiator be replaced every 2 years. In this video, I'll show you how it gets done on my Kawasaki Ninja. The reason for replacing the engine coolant is corrosion. Engine coolant is 50% water, 50% antifreeze, and it does corrode and interact with the aluminum engine block and the aluminum radiator. There will be some sedimentation occurring over time, as well as the system is not airtight. It shouldn't be made airtight. And because of these corrosion products, clogging up fine passageways inside the engine defeat the purpose of cooling the engine efficiently. The engine should be kept at as low a temperature as possible, given the heat of combustion and the friction of operation. So the coolant system's health is critical to proper functioning of your motorcycle. The job is fairly straightforward, is not too technical, needs only a handful of tools, minimal supplies, equipment, and just really a handful of tools. I'll show you exactly why it gets removed, when, and how to put it back together, with focusing on critical parts of the installation. So the first part of the job is draining the old engine coolant. Second part is flushing the system, and the third part is filling in the new engine coolant. So let's get started with draining. It's as simple as removing one bolt and removing the radiator cap. So let's get started with that. The one bolt that gets removed is on the underside of the water pump at the lowest point typically, and all you need for it is one wrench to remove one bolt. You're also going to need a bucket of some sort to capture the old engine coolant. And if you follow the largest hose exiting the radiator, follow this big hose line here, you're gonna get to the water pump there. That's how it kind of looks like when it's intact. On the underside of the water pump, you can see two bolts at the lowest points, but you can see four bolts: 1, 2, 3, and 4. And one of them is the coolant drain bolt. The coolant drain bolt has a washer, and the washer is important because it seals the coolant, make sure it doesn't leak. You can see this bolt here has a head with a little bit of a flange on it, but has also a washer underneath. Right next to it is a structural bolt along the perimeter of the coolant, does not have a washer underneath. This structural bolt here is also 30 millimeters long or so, whereas this one is just a drain bolt, 10 millimeters, maybe half an inch long, something like that. So this needs to be removed. I have already pre-loosened and I'm done my draining of the old engine coolant, so nothing is expected to come out, not even clear water, because I'm also done flushing my system. So this is how this drain bolt looks like. This washer is a critical part of the system. Like I said, it should seal. You may be able to see that it's got a circular dent line or score line on it towards the base of the screw. The aluminum washer needs to be soft enough, aluminum, to deform as the bolt is being tightened and seal against the chamfered surface there and against the flat surface there. Okay, so that's how this seals, because the threaded connection is not watertight at all. So if you find a replacement washer, manufacturer recommends that this washer be replaced with a new one, that it does not get deformed twice and potentially leak. But if you want to take your chances and reinstall it, hey, if it doesn't leak, it doesn't leak. But if it does, and if you already have fresh engine coolant everywhere in the system, and if it does leak after finishing and installing everything and you find that it leaks, if you take it out, you're gonna leak out some engine coolant while you replace this washer. It's not a big deal. You can just hold it in with one hand. If somebody can put another washer on it and then install it again, only minimal amount of engine coolant will be lost, and that's easy to refill. But just to plan ahead, you know, get ready for it. These are some of the implications or consequences that are involved. So this is draining. That's one point that you need to touch. And you also need to work on this bolt while you flush the system. So make sure that you capture all of the engine coolant, make sure that pets and dogs, whatever, don't lick it up from the ground, and there is no contamination. It's a toxic material. It's not super hazardous to the environment. Like I said, half of it is water, half of it is ethylene glycol, or so it's not especially dangerous to the environment, but it's not good. It's poisonous for the household animals, whatever, to lick it up. So there shouldn't be any on the ground, and there isn't. So what helps draining is if you take off the radiator cap. The radiator cap, to access it, of course, you need to remove the body panels. I'll talk about them towards the end of the video. To remove the radiator cap, it needs a quarter turn, like so. And at this point, it doesn't turn anymore, and it feels loose. This will crack it's a pressure fit. It will crack the pressure enough so that the drainage on the other side will happen faster. You can also completely remove the radiator cap, which you will eventually need to do. It's got a hook on the underside here, a black hook, which is hitting one part of the frame, not the frame, it's the radiator's frame. I hope you can see it there. It hits an aluminum stopping tab. So at this point you need to press down on the cap. I'm pushing down on it and rotating it another quarter turn. I need a little more pressure, maybe this way. Another quarter turn. Now the cap comes out. The cap also needs to be inspected. This should be clean on the inside. This rubber gasket here is also deformed, just like the washer that's sealing on the drain bolt on the other side of the bike. This also has the same mark. This doesn't need to be replaced, but it's seated against this flat surface there. It should be nice and neat and without sediment. The first reason of getting this whole system flushed and the coolant replaced. So make sure you don't enclose any folding petals and whatever. So I don't entirely take it off, I just kind of leave it on so foreign objects, organic matter doesn't fall into it, ants don't crawl into it, ideally. So at this point the hoses are still attached for draining, and the cap is loosened and the drain bolt is taken out. Everything is draining into a container that doesn't leak. So that's the draining part. Once the draining is done and the old engine coolant is contained where it doesn't get kicked and spilled, next thing is to flush the system. You can flush it in a number of several ways. You can use gravity and distilled water. I use a garden hose and no distilled water, and garden hose with compressed air, and I'm going to explain how these work. And so that's the next part, flushing the system. I flush the radiator and the hoses separately from the rest of the system. Let me just explain this a little bit on this side. This is why I disconnect the garden hose. I disconnect this coolant hose here with this number 2 Phillips screwdriver. It's about this simple. Make sure this is clean when you put on the hose again. Inspect the hoses. It should be pliable and really soft and flexible. If they get a little permanent indent from the shape of the hose clamp, that's fine. Make sure you put the hose clamp back on to exactly the same spot. That would be ideal, just to make sure they don't leak. And you see the drain, you can see there are dips in this coolant line, so not everything is gonna drain out from the coolant system. There's gonna be puddles here that need to be drained out into the same container, of course. But this is the point of flushing, so any remaining residual puddles are flushed out, as well as any sediment that settles inside the radiator and inside the engine blocks, fine passageways. Okay, so that's why I use pressurized air and pressurized water to actually flush everything, force everything out of the system. Okay, and let me show you how I do it. I also disconnect this hose here from the water pump. That's why it was off. The hose has to come back when you install it to this tab there. So now I have this hose leading to the radiator there, and I can flush just the radiator from one end to the other end. I can just isolate the radiator and work on the radiator itself. So what I do is I put the cap back on properly, like so, and at this point I want to point out there are some other smaller hoses connected to the radiator, and I have removed the coolant overflow tank, which is mounted here on the side with this 10mm bolt, single bolt. Just remove it, take it out. So this needs to be flushed, as well as the radiator needs to be flushed, as well as the remaining lines and system components need to be flushed. This gets flushed in the sink using tap water, lend a little bit of pressure, whatever comes out of the faucet, and I use a bottle brush and brush it clean inside and out as much as possible. There's some corrosion here. This was disconnected and the hose was cleaned out, and the little tap sticking out from the reservoir was also cleaned out, so they have been reinstalled. I don't just plug it back. This was also cleaned out on this side, and this mating surface here was also cleaned out, so this is ready for reinstallation. But this was done in the sink and was meticulously cleaned and then dried. I'm not too concerned about any mineral deposits inside this, but that's only based on the fact that we have really clean tap water here, or faucet water, and it's really soft. It's not distilled what comes out of the faucet, but it's really close. If you have hard water in your system that leaves deposits on say glasses in the kitchenware when you do dishes, if you have hard water, you're gonna have to might want to flush it with distilled water after cleaning the crud and the sediment and the deposit out from it. Okay, so clean it with tap water and then flush it with distilled water. Same goes for the tank. Force out most of the crud and sediment with tap water. It's soft enough, so I don't do a distilled water flush, and that's just based on the hardness of the water. I just hold the garden hose here on this connection point on the radiator side there, and water is gonna be shooting out on the this side of the water hose or a coolant hose there. So I do this for a minute and just flushing it and flushing it and flushing it at full force, and any sediment that's in the system, settle down or whatever, is forced to move out. Very straightforward. Again, I have soft water, and I don't have any mineral or major amount of mineral depositing from tap water, so I just leave it as is. Don't use distilled water. What I do, however, is I come with compressed air. This is from a shop vac, so it's not compressed air from an air compressor, it's just from what a shop vac can generate. And you can see that this part of the hose is kinda matches that size there, and I blow out the water content as much as I can with air. The reason for this is that I want to remove from the radiator as much, not so much the mineral deposit, but as much water as I can, because it's not gonna dry out or not gonna drain out too effectively. And this mix here is a 50-50 mix. Let me see, does it say so anywhere on it? It doesn't, but on this side, maybe it's on this side. Yeah, it says it's this one is a 50-50 mix here that we have in this case here. So that means 50% water, soft water or demineralized or distilled water, and 50% antifreeze, ethylene glycol. So if there are little water droplets inside the system, that's gonna dilute this one. Instead of a 50-50, it's gonna be a 49-51. It's not a huge deal, but I really don't want to unnecessarily dilute it with any amount of stagnant puddles or whatever I I just don't want to further dilute the antifreeze, even if it's just a microscopic difference. Okay, so that's why I just blow it out with compressed air, but it's with the shop vac. I do the same with the rest of the system, of course. So drain out what I can. That's clean water after my after the engine flush. Run the garden hose through it again, forcing water in here with the drain bolt loosely in place, so not much is squirting out at the drain hole there, or drain port, and just forcing tap water through the system. Again, it's based on its softness, and I want to flush out, and water is gushing out here, water is also gushing out here. It's gonna partially refill the radiator because water is gonna come through here through the smaller hose, so it's gonna run down here, and that's how I flush out this system. Okay, I want to forcefully dislodge any sediment wherever it may be stagnating or settling in the system. After the garden hose, you're welcome to do a gravity fed distilled water rinse, but again, just based on water softness, I don't do that, but I follow it up again with the shop vac and blow out all the water that I can. After all that, I also open the port for draining, and any puddles or anything that can dilute, or any mineral film or deposit that can be left from however soft this water is, it's still not distilled water. I want all of it removed, helping with the compressed air a shop vac can generate. So that's basically flushing. That's how I do it. I'm not saying that's how you should do it or that's how it should be done. I'm just saying that's what I do. I really want a clean radiator with absolutely no chance of sediment, and as little mineral deposits as I can possibly achieve without buying commercial flushing solutions and that kind of stuff. Filling in is fairly straightforward from here on. Connect the hose there, tighten the hose clamp, connect the other hose there, tighten the hose clamp, put the drain plug back in. The tightening specification is 78 inch-pounds of torque on this one. If I haven't mentioned it, it's gonna be in the video's description, which is 78 inch-pounds of torque is about 6.5 foot-pounds of torque, or 8.8 Newton meters. So that needs a torque wrench, a small one that's calibrated to inch-pounds, preferably, please. Not a 2 foot long, not a meter long torque wrench, just the baby torque wrench, just like that. And fill in the system, install this overflow reservoir, very straightforward. Connect that one hose to the radiator body there and put that one bolt in. I don't have a torque specs number to this one, just tighten it. It's gonna compress this plastic a little bit, and let's think it through a little bit. If you crack the plastic, or this is a steel bolt going into an aluminum radiator, aluminum is gonna lose all the time if you over tighten this steel bolt. It's an important bolt that this overflow tank be fixed in place, but if you over tighten this, and it's gonna strip out the threaded insert from inside the radiator. Good luck with replacing your old radiator with a new radiator now. Okay, so that's just tighten it gently. So that goes there, and you need to fill in your new engine coolant. Now this one is a long life engine coolant, or extended life engine coolant. That's how it's advertised there, and it says it's good up to 5 years and 250,000 kilometers. It's about, I don't know, 200,000 miles, something like that. I'm just guessing the number, but roughly. So it's supposed to work for all kinds of import and domestic vehicles, and let me just get you a close-up here. You can kind of freeze the frame and you can read it in English and French on this particular label. This is why the freeze up point and the boil over point is why I totally try to avoid diluting it with any stagnant pools or puddles of water in the system. So that's the warning label on it. That's how this works. It's gonna need a clean funnel. Filling in is fairly straightforward. Keep filling it in. It's gonna be kinda, you can see when you fill it in from the top that it's gonna be coming to the top. Run the engine for a few minutes. Wait until all the air locks, because now the hoses are filled with air. Either the external hoses or the internal passageways inside the engine are partially filled with air. So wait for the system to work all the air locks out from itself. The air is going to be bubbling out through this. There should be some liquid in this one too. And keep filling in engine coolant into the radiator. You'll see that the level drops as the engine uses it and works the airlocks out of the system. It's gonna keep dropping. By the time you're done, it's a little bit of time and a little bit of experimentation or settling. And let me just show you here in the shade that there is a low line on this reservoir there, and there is a high level there, or full. So keep the engine coolant level somewhere there between full and low, and that's when you're done. When the engine is at full operating temperature, it's not overheating, and the engine coolant level is correct in the reservoir somewhere here. Okay, so that's how that looks like. Now a couple of things about the fairing. The turn signal here needed to be disconnected, and this is its connector. It's an evil one because dirt clogs it up. This is how the shape looks like, and it was designed to work with pushing it down here, but pushing it down here didn't really raise the tab at the front. That would be the design idea, but it wasn't working. I had to lift this T-shaped tab in the middle of the connector that you're looking at with a needle or with the edge of something from behind. I had to kind of hand pick it. I think I used just a needle or a safety pin. So this was a little miserable to disconnect because it gets clogged up with dirt. What else gets clogged up with dirt is that you have a body panel here on the underside of the, this is the light here, this is the front of the bike. So in this panel, which is just like this PVC, very simple plastic, you can see some holes. 1, 2, 3. These connectors that go in here were especially miserable to remove. I'll show you where they are and how they look like. Let me just put on the tripod here. I've got the connectors here in this little box here. There. So here is one of them. So this is how they look like when you face them. That's all you see of them. How they work is, I use this putty knife. You can see there's a scratch line in the middle. You have to depress the middle, and then they can be withdrawn from the hole in theory. But in reality, these claws here that expand on the underside get filled with dirt. So once dirt clogs them, you will be usually unable, in some cases it's very nearly impossible to depress the middle, and you kind of have to dig out this connector with a little bit of loosening of the dirt and a little bit of misery time to get these functional. Okay, so once they're clean, this is how they install. Put them in place this way and just do this, and then they are holding in place, but of course they are going to fill again with dirt. So that was miserable and took some time. Another thing that was difficult, these 3 pieces really remove easily, don't want to spend any time on it. This is the inside of this turn signal. The foam hardens and deteriorates, but don't worry about it too much. This is the inside of this turn signal connector, and this is the little tab on the top of it that interlocks with the connector, with the female connector, and it was hard to separate these two here. and that's what needed lifting on the female side. What was also difficult on this panel, you're gonna need a bolt here to be removed, so get ready for a 10mm bolt. The same 10mm wrench that gets used for this is the same that gets removed the overflow tank, that clear tank. What you have here along this edge is two bolts that look like this. Just this one here, this is one of them, with a coarse thread on it, and this gets threaded into an adjoining fairing piece. So I'll show you on the other panel where they go through. So this is where one bolt gets threaded into. You can kind of see that a screwdriver or a hand is difficult to fit in here already, so you kind of have to bend this a little bit, but don't break it off, of course. You see where it bends, and I had to remove the mirror to allow enough flex in the panel to remove the second screw, because the second screw is even further ahead here, and as is, there is only one finger's worth of space. So if you remove this mirror, two bolts here, very straightforward, remove the mirror so that the panel can flex out a little more, careful not to break it. And I had to tighten it, not with a screwdriver, but with or remove it. This is the screwdriver that doesn't fit. Just take a screwdriver bit, and I worked on the screwdriver bit with, I don't have it here, with just a wrench. Just an 8mm wrench or whatever millimeter wrench can grab just the screwdriver bit itself. So you kind of make up your own screwdriver with a small enough wrench and just the screwdriver tip in order to fit your hand and wrench just here, just to get this bolt, just this bolt here tightened. Okay, so that's where the second bolt goes. That's a little bit of a miserable time. But before I put the body panel back on, I only want to put the overflow reservoir back in place, not over tighten this, and just to stabilize the level to make sure that it's spot on and you make sure that it's not leaking anywhere. Once I've done that, then I can proceed and put the body panels back on, including turn signals. So for a while, I don't know, for half a day, whatever, I am not gonna, maybe ride around a little bit without a turn signal on this side. Turn signal on the back is not affected, that works flawlessly. So, it's a long video, thank you very much for watching, but those are some of the critical points that I wanted to point out when it comes to replacing your engine coolant.